Hello, welcome to the tutorial. Today we are going to design a visual search experiment. Now what happens in a visual search experiment? You have a target which is predefined, let's say an alphabet T as is your target, and a bunch of distractors which are not T's, and the participant will have to search through those distractors and find T and press a key on the keyboard or bring the mouse cursor towards the target T. So that's going to be the task. So we will have a bunch of distractors and a target, and participant will have to search for the target. Now let's start with, as usual, let's start with the fixation. All right, so we will have the fixation here, and let's call this fixation, which is going to stay for 1 second, and it's going to be a cross in the center, and let's go by the defaults. Okay, maybe reduce the size a bit. Okay, so we have the fixation. Now we need targets and distractor, and of course the response, which will come to the response in the end. We need the target and distractors, and we know the target is T. Okay, now let's go ahead and add T, which is going to be basically a text component, and it's going to be T. Okay, so T is going to come on the screen. Let the duration be infinite until key press. Let's call this the target. Okay, so we have the target, and position is going to change, and we need random position for this. We'll come back to the position later. So we have the target here, and so we have defined the target. Cool. So we have the target component there. Now we also need a distractor, right? That's again going to be a text, and that, I mean, I'm just adding a component which I will delete later. This is just for demonstration purpose. So this component is going to be so the distractor is going to be L. Okay, L is our distractor. All right, let's call this distr. Okay, so we have that, and again time, let's keep it 0. Okay, now we need to make a bunch of changes to this distractor. One, it's not just one distractor, right? There's a bunch of distractors. So the least efficient way to do that is to go on adding more text components and calling it distractor 1, 2, 3, and 4, which is going to be inefficient and might not serve the purpose. So we might have to write a bunch of lines of code, to execute it. So let's compile the Python script. So this is one way you can sort of play around with the coding component. So when you compile the code, so this is the code of whatever we have currently created. So let's go and search for our component distr and see how it looks inside the code. All right, so this is how it looks inside the code. Okay, and you can see the target above that. So there are like a bunch of parameters here. What is it going to be? Is going to be L. We defined it as L. Then the position, then height, orientation, and the font style and stuff like that. So let's copy this. This is the line of code that we are going to work with. All right. Okay, so done with the coding part. So let's go back and insert this code into a code component. Okay, let's start a code, and at the beginning of the routine, you insert that. Now we no longer need this, right? We have pasted it in the distractor. So let's remove it. Okay, so we have the code here, and there's a bunch of changes that we need to make. Okay, we need firstly multiple distractors coming in. So what's the best way to add multiple distractor? Yeah, so you have to have a for loop around it. So you loop through in as many times as you want and create as many distractors as you want. Let's say we are trying to we need 10 distractors. So let's define our number of distractor as say 10 and so we have the numbers and we need to start a new list which is sort of empty. We'll come back to this and see, I mean we'll see what this means later. So we have an empty list. Now we need to add a for loop. So this is how you sort of insert a for loop in on Python. So you say for I in range of num distractor. Okay, so yeah, so this means that for the range of whatever number we assign to this variable, this for loop is going to loop through that many times. So make sure that now you hit a tab here so that yeah, indentation is proper. Sorry, okay. All right, so we have a loop around this. Now that's not enough, right? We need to save this. So each iteration it's going to create a new distractor. So we need to save the distractor. That's the reason why we started this empty list. So now let's go ahead and add stuff into the empty list. So which is distractors dot append dstr. So basically now each time the new distractor that is created will get stored inside this list named distractor. So that is going to be what is happening. And now final step is we need to call it, right? So we need to call it how many times? We need to call it num distractor times. How many distractors do you want? That many times you need to call it. So again, the calling is also going to be a for loop. So we say for dstr in distractors, which is basically the list that contains all the distractors. Distractors. Okay, so how do you call it? You call it by using this function. If you doubt, from where these functions are coming, you can, auto compile your code and see where the calling is happening. So this is the line of code that will draw the distractor on the screen. So basically, it's going to happen 10 times because if you change this number from 10 to 5, it is going to be coming onto the screen 10 times. Okay. Now we also need to stop it from drawing this distractor. So at the end of the routine, we need to paste this line of code and say false. Okay, so that is very important. So don't miss that part. Now in a typical visual search task, let me show you. This is kind of an example that we saw in the lecture. You have a bunch of distractors and target, and you need to plot the reaction time. That means time they took to find the target and make the key response against the set size. Here set size means how many distractors, or in a sense how many total number of items are there on the screen. So essentially we want the slope of this set size by reaction time function. So in order to do that, we need to have multiple distractor conditions. That means a condition where the total number of distractor is 5, total number of items is 5. So total number of items means distractor plus the target. So a set size of 5 means 4 distractor plus 1 target. A set size of 10 means 9 distractors plus 1 target. Okay, so we need two conditions. A condition where the set size is 5 and a condition where set size is 10. So let's try to alter this code a bit and say, okay, at the beginning of the routine, if random of, so we have already seen this function. This function gives you a number between 0 and 1, and we've used this sort of strategy before. So if random greater than 0.5, then you say num distractor is 5, okay. Else what is the sort of the other possibility, which is when we want the distractor to be 10, okay. Number of distractor is equals 10, okay. So we have this line of code that will basically say, okay, if you're at the beginning of the trial, half the time it is going to be 5 distractors, and the other half it is going to be 10 distractors, okay. So we got that here. We also need, I'm just going to paste this thing here. We also need one more line of code, which is that we need to save this, save what was the distractor number or set size at that particular trial. So this is the line of code that will enable you to do that. So you say this experiment add data num distractor. This is basically going to add a column in your on your data file, and it will tell you what the condition was. Was it set size 5 or was it set size 10? And we no longer need this, so we have to remove this. Okay, so we've got all the code components here. So let me walk you through this. It says, so it starts with saying, okay, half the time the number of distractor is going to be 10, the other half of the time the number of distractor is going to be 5, and you are adding a column so that that particular number is added, and you are starting an empty list, and so that empty list is going to be populated by the distractors that you're going to create. If it is set size 5 distractors are going to be created. If it is set size 10 distractors are going to be created. Now there is one, couple more things that you need to change here. We don't want the distractors to come at the same location all the time, right? So if you are creating 10 distractors and all of them are coming at the same location, it doesn't make sense, right? So we need to have a unique position for each of the 10 distractors that we are going to generate. So if you need a unique position, again we use our favorite random function. Now this function is going to give me just the positive values, but I would need negative values, because we've seen that the center of the screen is 0, 0. So anything to the left is going to be negative, is going to be a negative number. So if you just use random, if you let's say you say random in the x-axis and random in the y-axis, you're essentially going to see your items coming just on the right side or top right side of your screen. So you want it to be spread out. So you just subtract it with 0.5. This one should also get subtracted by 0.5. Okay, so we've randomized the locations, and we also need to randomize the orientation. See, we don't want the alphabets to be always upright, right? So that's the default, so we want to change that. So let's say, okay, this is going to be random number. So we've already seen this function before. It's going to be, it's called randint function. If you say randint of 1 to 360, then it's going to be a number which is drawn randomly between 1 and 360. So we have that here. So okay, so again coming back, distractor is a empty list. So we are starting a for loop where we say I to in the range of num distractor, which is going to be 10 or 5 depending on the depending on each trial. And now here we add a line of code which we copied from the Python script. Let me just blow it up a bit for you. Okay. It's going to be text L with a random position and random position and random orientation. The rest of the parameters we are keeping constant. Okay, so we have distractors.append which is going to create the array or basically the list of distractors, and again this function will call the distractor on the screen. So we are good. Okay, now we have the target. So let's okay, this looks good. Now the target, again we need the target position to be sort of random, right? So we have to basically copy whatever we've written in here. Okay, so here we've defined the location or position of the distractor as a random number. So we just need to paste it inside the location part of the target as well, and make sure that the spatial units are kept at experiment settings, because if you change it to pixel, then every values will have to be changed. So we have made, the random function is giving you within the range of 0 and 1, and if you keep the experiment setting, the spatial units will again be between sort of -1 and +1. So let's keep it from experiment settings as the spatial unit, not as pixel or anything else. Okay, we need to set this every repeat. Color is going to be white. Everything else remains the same. Let's add a mouse response. Now, mouse response, I mean, you could use keyboard response. We've been using keyboard response. So let's, for a change, add a mouse response here. Okay, so in the mouse response, you can specify what is the key that you need the participant to click, and name in the sense name of that component. So here you can see the name of that component is target. You give that name here, so you can basically change this from any click to valid click, which means if it's valid click, or it will move forward only if the target is clicked. But it's okay, we are okay with incorrect responses, so that's fine. In the data, you have to say what is the parameter that you need to store. So you need a routine as the parameter to be solved. Rest of the things can be set to default. Okay, now we will keep we will keep the fixation throughout the screen. So let's remove this. So we have the experiment ready. Let's go and add a loop so that it sort of appears for 5 times. Okay. So again, mouse component should also be until response. Okay. All right. So looks good. There is a syntax error here. Let me try to see what that error is. It should be okay. Okay, fixed. Now it could have been some typo that I made. Okay, so we have all the code components ready. Again, there is a syntax error here. It has to do with this line of code. So let's be safe. Copy and paste it here and say false. Okay, so good, looks good. Okay, now we should see our visual search display coming on the screen, and time to respond by clicking on the target. Now you will see that I'm not giving a full screen window to the Python to show the stimulus. So some of the stimulus would be outside of the window, but if you run it on full screen, it's going to be inside the window. So just a forewarning. All right, so now let's run this. Yeah, one quick correction. So in the mouse component, you need to make this on click, not on final. So final was the default, so this should be changed to on click. Now this looks good. I mean that is important because we need the time duration between the stimulus onset and the mouse click, which we call the reaction time. So that's why that change was important. Now we should see a visual search display, and the set size should either be 5 or 10, and that should be in a random fashion, and the task is to click on the target. Okay, the target is T. I'm going to click on T. All right, you can see the distractors are sort of changing its orientation. T, again T, here is this, and final trial T. All right, so we have that, and let's take a look at the data. Okay, all right, here we go. So this is the data file for our 5 trials that we performed, and what are the important parameters that we are looking for. Okay, here we go. So this is the time taken to make the click response. So that is what we call the reaction time. This tells you whether the participant clicked on the defined target region. If it did, it says, okay, it's basically telling you where the region where the mouse click happened, and it was in the target region. If it's outside the target region, it's going to be blank. So if it says target, it means that's an accurate trial in terms of correctly clicking on the target. So these 2 columns, very important. It tells you the reaction time and accuracy in this case. And there's a 3rd column here, which is also important for us. This tells you what was the reaction time, what was the condition in which a participant pressed the key, which means here the condition is either set size 5 or set size 10. So you have data for set size 5 condition and set size 10 condition, and typically you would see that in set size 10 participant take more time as compared to set size 5. All right, that was visual search experiment for you. Thank you.